Hi guys, this is Jordan. Welcome back to the 7th video tutorial for the CSC251 Advanced Java Programming class. Today's lesson is going to be threading. The topics covered will include what threads are, how multiple threads can be useful, the dangers, and we'll end with a code example. So let's get started. Threads are essentially lightweight processes. They are similar in that they are self-contained and have their own memory, but they require fewer resources to create and to manage. Threads are created by processes, and each process has at least one thread. Threads share the resources of the process that creates them. This has the advantage of being able to easily share data and code between threads, which is more complicated when using multiple processes. On the other hand, this means you have to be careful when more than one thread is trying to access a resource at the same time. I'll come back to this later. How is multi-threading useful? It can greatly improve the performance of applications. Many intensive algorithms can benefit from having their steps split up into multiple pieces that are done side by side. Sequential algorithms, or things that have to go one at a time, won't really benefit, but anything that can be done side by side will. An example I'm rather fond of is port scanning. Scanning one port at a time is very slow. With threading, you can scan multiple ports at once. This is a perfect example because no thread needs another to finish before it can do its own work. Obviously, if you can do multiple things at once instead of one at a time, you're going to finish faster. That's one of the main benefits of threading. Although I've somewhat just covered this, let's go over when you should use threading. Background processes and I/O are two of the best times. With more than one thread, you can have one doing a background process and another keeping the main program responsive. This can prevent the sort of freezing that was common in single-threaded programs. Input and output is another good time to use threads because it's one of the main causes for hanging and long waits in programming. I've gone over some advantages and uses for threading, so now let's go over some problems and issues. Threads share resources, and while it lets them easily communicate and share code, it can be dangerous as well. If we have multiple threads, they may try accessing something at the same time, and that can cause problems. Locks are a method of making sure that no more than one thread has access, or at the very least writable access, to a resource at the same time. For an example of why this is necessary, suppose you had an array and multiple threads that are using it. If the threads check the array one at a time to make sure there's free space, you won't run into problems. But how can you do that? If you force the threads to go in a certain order, you defeat the whole point of threading. However, two threads might think there's free space at the same time and then try adding too much to the array. The solution is locking. This way, threads can still do concurrent work, but if they need access to a changing or limited shared resource, they'll have to take turns. Be careful. Locks can be dangerous too. One of the biggest problems resulting from locks is called deadlocking, where two threads each hold a lock on a resource the other needs. In this situation, neither thread will finish. Another problem that can occur is called live lock, which is essentially when threads are too busy responding to each other to get work done. Think of two people in a narrow hallway trying to pass each other. One moves to the right and one moves to the left, and then they keep doing it over and over to try and get past each other, with neither getting through. Finally, if a thread that's doing critical or crucial work hangs, the whole program can hang as well. Before I get to the code example, I'm going to very briefly discuss thread creation. Let's start with the thread class. The thread class has an empty run method that must be subclassed. A thread ends when its run method ends, whether it finishes or runs into an exception. There are 8 thread constructors, but the most useful and common are simply thread and thread with a string, which, as you might suspect, gives the thread a name. There are 2 main ways of writing the run code for threads. First, you can implement runnable, or second, you can subclass thread. The first is more extensible, because you can subclass something other than thread. The second is easier for simple applications. Now let's go to a very simple example program. This one simply creates a thread, starts it, and quits. This example uses the subclassing thread method instead of implementing runnable. As I mentioned before, run must be subclassed, and you can see that here. I call super in my constructor to give the thread a name, and use the current thread.getName function to, you guessed it, get the thread's name. Notice the start function, which is how you start threads. Let's run it to make sure it works. And there we go. Just to review, today I've gone over threads, how they're useful and when you should use them, some dangers and problems with threading, and a code example. My next video will be on networking, so until then, thanks for watching.